All right. Good morning, good afternoon, good evening. My name is Chee-wai, and I'd like to demo to you how to make use of Docling to prepare uh, a data for creation of a vector database. And after that, we will demonstrate a few queries using LLM RAG application that will answer questions that is related to the contents in the vector database. So this is related to the final year project called Intelligent Document Retrieval and Questioning Answering System. So in this project proposal, there was a recommendation to make use of a facility, or I should say an IBM library called Docling, which has a very strong reputation for being the extremely effective and efficient in preparing documents for conversion into a vector database. Right. So if you look through the proposal here, you'll find there are reference to this library. So let's doc link there. Right. So doc link. This one. Okay. And along the way, we will examine some other technologies as well. Okay. So the two documents that we are concerned with in this exercise are very, very simple documents just for demo purposes. But this document does have some challenges. And one of the document features I want to demo is the ability to take into account images in our document. So this is actually the title page of annual report for the SIA group. So annual reports are pretty long, so I'm not going to use Docling to process the entire report, but I'm just going to do it for the title page for demo purposes. And for that, there's some challenges. Like I said, I want to show you how can we take into account images in your document. And the other document, which is not really related to SIA, is something called food regulations. So here, what we have is that there are actually many tables, okay? Many tables, and some tables are in fact are not in the portrait orientation. For example, you could see that like this table, you see, yeah, it is in a horizontal orientation. So how do we take into account all these little things in documents that computer programs are quite challenged to do. As humans, we can just flip the document and read it. But sometimes you find that for computer programs, they're quite challenged to do this. So let's try to make it as easy as possible for our computer programs or for our RAG applications to make sense of information like this. Okay, so all the code that you see in this demo are available here. Okay, it is a public repository, and you can just download and run the notebook to get a feel of how these things work. Now, of course, in the proposal, the original proposal, there's lots of information and lots of sample code as well. Please do try that out. Right, but I realized that this sample code, a lot of it is lifted off books. Not to say they're not valid, they're actually very useful sources of reference, but they may not run coherently as one complete demo. Okay, so I'm just trying to address a little bit of the gap. Okay, so if you dupe the repository, you open up in a VS Code, this is what you have. Now, for demo purposes, I've created three loosely speaking utility files. One is Docling etu. So this one has has several functions that make it easier for you to read a file and then convert it to a form where it is suitable for eventual conversion to a vector DB. Then I have another one called Gemini Vision. So this one just takes an image file or a URL or resource link to an image file and then use Gen AI to tell you, okay, what is this image about? Now, what is the purpose of this? Afterwards, when I explain, it will be clear. Then finally, there's a query util. How do you then handle a query, or rather, I should say, how do you take a text string? There is a question asked by the human user. Then how do you make use of LangChain to query the vector DB that you have created? All right. So there's just three, like I said, broadly speaking, utility files. Okay, so let's just get started. Now, this is a notebook. I'm sure you're very familiar. If you're not, then please go and revise. So first thing, we just do import, nothing special here. Now, so the first function we call is .etu process document to MD. MD stands for markdown. All right, markdown. Now, these documents that we have here, that we want our application to be able to provide intelligent answers for, are actually PDF document. Okay, so we want to convert it to markdown that will make it easy for conversion to vector DB. Why is that so? Because markdown is all text, it's all ASCII text. But despite that, it retains the structure of the original document, including things like tables, annotation, headers, etc. And also with a little bit of processing, it can even retain information about images in the document as text so that this information is not lost. Now, these are just logos, but if you just think, what if there are bar charts, pie charts, line charts in your PDF document? How do we ensure that that information is not lost? Okay, and this is the where markdown becomes very, very useful. So here we say process documents to markdown. So we simply say, hey, what are the files in your input folder? Here are two files, which is these two files, which is actually this file and this file. All right. And I say, well, and I say no image annotation. Now, Docling has something called image annotation. Now, according to documentation, it says that when I see an image, I can automatically describe what the image is. But I realize actually that doesn't work really well. So that's why in my function, I say, hey, I give option of not using image annotation. And the output of this is that you will create a corresponding version of the PDF file, but in the MD form. For example, annual report sets.pdf, then you have annual report sets.md. Food regulation sales.pdf, you have food regulations.md. Okay, so let's take a look. What is the MD version? So if I open this, which corresponds to this, nothing special. Now we will expect the text to come across nicely, and that's exactly what has happened, right? SI Group portfolio figures as of 31 March nothing special. But you also realize that the logo, for example, the Singapore Airlines logo and the Scoot logo have been converted into text. Right? The image showcases the Singapore Airlines logo. It features a stylized gold-colored bird in flight above text Singapore Airlines, the dark blue blocky font against a light blue background, and so on and so forth. Scoot, the image showcases the word Scoot in black, rounded lowercase letters against a bright yellow circular background. Okay, and then if you look at this one, a very boring document, lots of text, lots of table, but I just want to highlight one particular example. Just be patient while I look for that section where it has a table. Okay, here, there. Okay, so this table, minimum amount of sweetening agent per million. Okay, and what happened to this table in the makeup document, the markdown document? So let's look for it. Oh, in fact, you have it. You see, maximum amount of sweetening agent in parts per million. Okay, it has converted it neatly to text in a easy to read format, right? The maximum of amount of certain agents in parts per million. Then you have like stereoglycosides 200, 1258. I don't know what this means, but you can see it corresponds to the lines here. Yep. Let's look for the first one, the first there. There. Stereoglycosides. Stereoglycosides. See, stereoglycosides 200, 125, 125, 60. Now, this column, right, is meant to be read this way. Now, if in computer programs, it'd be very, very challenging, right? Because, computer programs just go left to right, left to right. But here, they converted it to horizontal format. You see, you read this way, which makes it very easy to process. So the markdown has this advantage, right? It retains the structure of the document. For example, this is a header, right? Hash header. And the header is also retained, you see? Permitted sweetening agents in selected foods and the maximum permitted levels. Yeah, that. But then, right, Docling is also very good at looking at very complicated document structures and then converting it into a form where it's really, really easy to understand, but yet the meaning and structure is not lost. So this is one very big advantage. Okay. So here, okay, first step, we're going to process the documents, take the files from the input folder from here. There are two files, two PDF files, and just convert them into markdowns. Right, so if you take a look at the docling.util, the process documents to MD function, it doesn't really do much, right? So some admin, and actually there are many formats that supported. These are PDF, but you can experiment with a Word document, text document, right? Do your own research to find out what formats are supported. Quite a wide number of formats are supported. Okay, and there's some library function calls here, okay, that will create the markdown documents. Okay, so yes, AI service provider. Now, after that, I call another function, process markdown folder, because after you have called this function, okay, the corresponding markdown file is located here. So I'm saying, hey, go to this particular folder and then process markdown folder. Now this name perhaps is not so apt, but basically what I'm trying to do is to go and see for those places where there is an image, then I'm going to pass the image, the raw image, to Google Gemini and ask Google Gemini to tell me what is it. Okay, and how does it do that? So when I do this process document to MD, when I encounter an image, it actually dumps it out. So if you look at the folder here, let me go back to Docling, docling.util, yeah? Okay, so here, and that is output save as markdown. And there's actually a image file. So let me open up this one again. Look at this. Right? Output MD, Okay, inside this folder, this markdown folder, okay, there is actually a image. All right, and they're going to pass this image along to Google to say, hey, what is this thing talking about? Yeah, what is this thing about? Okay. Okay. So process markdown to folder. What does this do? Process markdown to folder, which is this function here. Process markdown to folder. So it just runs through, right? Look for places in the markdown file where they say there's a image. Then you take the image and then you call this function, describe images and update markdown file. As you can see on the command station, call the function to update the markdown file. Okay, so what it does is that it will pluck out the image. Okay, pluck out the image. Extract the file name from each image tag. Then we will then call Gemini Vision to analyze the image. And then the Gemini, of course, will tell, oh, what exactly it is, and then just write the result back to the markdown file. And that's actually how you get these, right? Okay. All right, you can see here, see, the image is embedded in the markdown file. The image is embedded in the markdown file. So when you call the function, okay, processed markdown folder, it will run through each file. And then for each file, you will see, is there some reference to an image? If there is a reference to the image, then we will call describe images and update. So ask Google Gemini and say, hey, want to know this image? And then write the result back to the part of the markdown file that's just below the image. This, I see, encounter this. Hey, Gemini, what on earth is this? And Gemini said, hey, this is what it is. Same for the other one. So that way, you don't lose any information about the images. Okay? So this will take a while. So you do. Okay, fine. So I have a markdown file. But that doesn't do the RAG application any good, because a RAG application basically needs to run a query against a vector database. So we need to take the markdown documents and convert them to vector database, which is this function, create Chroma vector DB. Okay, now there are many vector DB products. Okay, so Chroma is free. Another one that's very nearly free because they're so generous, the credits will be Pinecone. You can try that. But here we use Chroma, and Chroma has advantage of writing the vector DB to your local drive. So you don't need to worry about cloud access. You don't need to worry about writing to cloud. That's exactly what I've done. So I say, hey, take these two files here and then create a vector DB. So if you look at the function, create Chroma vector DB. So create other here. I'm just going to dump it into this folder called Chroma vector DB. The text splitter is based on character text. And the model to create the vectors, we'll get it from a Hugging Face. Yeah, Hugging Face. Now, there are many different choices to explore. How do you want to split the text? Do you want to use a text? Do you want to use a character split, a token split, right? And many other parameters. And that's where you need to do a little bit of exploring. If you find that after you created a vector DB, your RAG application is not very good at answering questions, a lot of times it's because of this. How you do the chunking such that it will do chunking logically to maximize the chance of the application providing a correct answer. That would take a little bit of research, a little bit of experimentation. Okay, so you can play around with this. And likewise, you can also play around with this. Maybe different models, the way they do the vectorization may be a little bit different. The many that are available, you can go and try. And that's where you can add value to the project. In your final project report, you say, hey, you know, along the way, I tried the different models for creating vectors. I tried different vectorization models, where I get it from, what the strengths, what the weakness, and I tried the different chunking parameters, you know, what's the difference with outcome. And that will make your final year report more interesting. It comes across as more knowledgeable. It comes across as a valuable technical read, and that will increase the chance of getting a good grade. Okay, so do a little bit of research. Now the examples I show you all run, but these are very basic examples. So it's up to you to go ahead and improve upon this. Okay, now I think improve upon this is not correct. This is just a demo to give you some idea. Okay, this should not be your end product. You go and create your own application. Right. So okay. So basically, the result of this is a vector DB. So once the vector DB is up, then we can ask questions. In other words, right? These two documents have been vectorized into this vector DB, and I can ask question. How do you ask question? Now we're going to use a RAG application. Okay, meaning you're going to use a RAG application means that we're going to ask a LLM questions related about these two documents. So the LLM will refer to these two documents to formulate its answers. So which LLM to use? So in this example, I use Granite model from IBM. So you look at Query util, right? Query util. Okay, there, I use a Granite model. There's some parameters, so this one you have to do a little bit of experimentation, okay? Yeah. Okay, so let's see. And okay, the question. So I ask, what is the symbol of Singapore Airlines? The symbol of Singapore Airlines is a stylized gold-colored bird in flight above Singapore Airlines in dark blue blocky font against a light blue background. So you look at the document, there is no such words like this. But why is it I know how to do this? It is because previously, when you encounter this image, you pass this image to Gemini and ask Gemini, hey, what is this? Gemini return the description and you embedded it in your markdown file. The markdown file was converted to vector.db, which is used in this query. Therefore, it can give you a good answer. Okay, I hesitate to use the word good. It gives you a reasonable answer. It doesn't say, I don't know. Look, there's a good chance if you don't do that process of actually creating a description of this image, and you just create the vector DB based on this PDF document, you say that I don't know what's the logo. Okay. Then I ask a question that's totally unrelated SIA, but for this document, I say, general, what are summarize general purpose food additives, and it did so. This is nothing terribly fantastic. It's just basically a text search. Okay, if I say it, it's because of the quotes. Okay, just summarize this couple of paragraphs. Not very. I'm no expert in food processing, so I don't really know whether this is a good answer. And that's where you have to do a little bit of research. Let's say you choose annual reports. You choose 4 annual reports, okay, to put into your vector DB. You need to be somewhat familiar with the contents to come up with question to ask. And when you ask this question, you also need to know what is the answer you are expecting. So in the process of creating a good app, you must understand the underlying domain somewhat. Okay? Okay, I ask a question. What's the total number of passengers carried by Scoot and Singapore Airlines combined? Now, this answer, in fact, is provided here because Singapore Airlines and Scoot is part of the SIA group, and the SIA group carried 36 million passengers. But I want to demonstrate that actually LLM is in play here. You see, he says, to find the total number of passengers carried by Scoot and Singapore Airlines combined, add the numbers of passengers carried by each airline separately. According to contact, Singapore Airlines carried 23 million, and Scoot carried 118. Uh, 118 passengers. Now, it's a little bit incoherent, but eventually it says 23 million at 1 equals to 36 million, which is this number. So it makes some sort of prediction here. Okay, so again, it's not you get the right answer, but perhaps not in a very logical manner. So again, it's up to you to improve your final project. And I asked, why is there a difference between the logos of a Scoot and the Singapore Airlines? So you just say, well, the difference is because there's a difference. Okay, kind of a silly answer. It made me laugh when I see this, but it's not factually wrong. They are different because they're different and they describe the differences. And then I ask a question, compare the performance of Cathay Pacific and Singapore Airlines, but there is no Cathay Pacific mentioned. And to the LM's credit, it said the provided context does not contain specific figures or data based on Cathay Pacific's performance. It did not juggle up an answer. Okay, so your Granite model from IBM is actually quite logical, quite quote unquote clever in a sense, doesn't give silly answers. Then I say, advice on total tolerance of hydrocarbons in food. Now, this is a test of his ability to extract data from tables, which is often a challenge for rack-based applications. So it's a total residue should not surpass 30 ppm where multiple chlorinated hydrocarbons are used. Yada, yada, yada. Okay, let's see. What do we see here? Advice on hydrocarbons in food, not found. We just look for this. Okay, sorry. Okay, let's change this to hydrocarbons in food. Nothing. Let's try again. Should be there. Oh, wow. Wait a minute. Hydrocarbons. Okay. Oh, tell what. Let's ask a question on the tables then. So apparently that's not correct. So just bear with me. Let's look for a table and ask some questions related to the table. See if it comes up. There was a table that was in a slightly different orientation. Let's ask some questions related to that. This one. Okay. Maximum amount of sweetening. So I say this one. Let's say advice on or let's say saccharin. Let's see. What does it say? Oh, this. Let's see. It's doing a query. What are the maximum? The maximum are as follow: 300 parts per million for sucralose. Saccharin 300 parts per million, sucralose 300 parts per million in non-alcoholic drinks. Okay, you plucked the information from somewhere. I'm not sure whether it is here. Saccharin. Sorry, this one. This is saccharin. 300 parts per million. Oh, there's many possible answers. There are many possible answers. So okay. $160. For metal, for saccharin is 300 parts per million. Sucralose is 300 parts per million. Okay, so I don't quite know if this is the correct answer. That there. So it plucked out from somewhere. And the challenge is it doesn't know which value because there's so many reference to such a range. So therefore, actually, it plucked the value from here, is it 300? All right, then again, that's where you have to refine your application a little bit to see, okay, what is the most logical way to answer certain question. Now, this answer may not necessarily be wrong because actually there's a reference. You didn't say that you were you didn't refer to a specific part of the document, but yeah, but it did pick up some value. So therefore, these are some of the challenges you would have to address, right? So it's a complicated table like this. You know, what do you do about it? Okay. So I hope this is helpful. Then give it a try. And if any questions, certainly you can ask your supervisor or you can ask me. We'll be happy to help. Okay. Thank you.